Hey guys, today we're going to be starting chapter 6, which is the second of 3 chapters in unit 3. The start of this is going to be a lot of review of stuff that we just did and stuff from grade 9. We're going to be starting with like slope and y-intercepts and y equals mx plus b and all that kind of stuff. And then we're going to build on that, looking at other forms of equations of the line, so things other than y equals mx plus b to describe a line. So yeah, today we're going to be starting with a lesson called slope. Okay, so this is lesson 6.1. Just a quick reminder, slope is the rate of change of the dependent variable over the independent variable. These are the 3 different equations that we use to solve for slope. So either rise over run or delta y over delta x, which is just a change in y over a change in x, or y2 minus y1 over x2 minus x1. There are 3 different types of slope. Slope can either be positive, which means the line is going up as you move from left to right. It can be negative, which means the slope of the line is going down as you move from left to right. If you have a perfectly horizontal line like this one, which would be an equation like y equals 3, or something like that, that would have a slope of 0. And if you have a line that is perfectly vertical, so goes straight up and down, which would have an equation of like x equals 2 or something like that, that would have an undefined slope. If you try to calculate the slope of that line in your calculator, you would get an error message. A quick review from grade 9 of how to draw a graph if you're given the slope and the y-intercept, like you would be if you were given the equation. So the first thing that you do is you plot the y-intercept, which is our b value, which is the constant, the number that's by itself. So we'll plot that first, so it's positive 5. It'll go on the y-axis. And then we're going to use our slope. So this is our slope. It's always right in front of our x. And I would recommend writing it as rise over run, which in this case would be negative 3 over 1, because any whole number can be written over 1. And then we use that slope starting at our y-intercept, and we rise by negative 3, which means going down 1, 2, 3, and then we run by 1, so over 1. So our next point would be right there. And then I could do the same thing from this point. I could go down 1, 2, 3, and over 1. And the next point would be there, and we can just connect them with a line. Okay? You wouldn't normally actually like draw in how you're moving from one point to another, by the way. The next thing that we're going to look at is finding half of a coordinate. And there's a bunch of different ways to solve this. We're going to look at 2 of them, though later on in this chapter, when we learn about the slope point form of the equation of a line, there will be a 3rd way of solving this. And we'll start with 2 ways to solve it for today. Step 1 is going to be to find slope, or to calculate slope, if it's not given to you. In some questions, you'll be given the slope. In others, you'll have to calculate it first. And then, like I said, we're going to look through 2 different ways of solving this. But regardless of what method you use, you always have to start by finding the slope or being given the slope. So for example 1, we're going to look at if you have, let's say, 2 coordinates, like negative 2, 1, 4, and 10, and then the 3rd coordinate you only have half of. Okay, so this is what it means when it says finding half of a coordinate, where you're given a coordinate and you're missing one of the values. So step 1 again has to be find the slope. So we're going to start by doing y2 minus y1 over x2 minus x1, using the 2 full points that we have. So this will be x, y, x, y. So we'll do 10 minus 1 over 4 minus negative 2, which is 9 over 6, or 3 over 2 would be the simplified version of that. So yeah, so in this case, we start by finding slope, as always. Find slope. And then in this first method that I'm going to show you, the second step is going to be to find your b value. And you do that by using the equation y equals mx plus b. And you're going to plug in your slope that you just found. And then you're going to pick any of the full coordinates and you're going to plug it into where the x and y is. So I'll show you what that would look like. So we have y equals mx plus b. I'm going to use this coordinate just so I can use whole numbers, but it doesn't matter which coordinate you use. So I'll put 10 equals 3 over 2 times 4 plus b. And then I'll solve what 3 over 2 times 4 is. So I plug that into my calculator like this, bracket 3 over 2, close my bracket, and then times by 4. So I get 6. And then I'm going to move my 6 to the other side to isolate b. So I'll subtract 6, and 10 minus 6 leaves me with 4 as my b value. And then step 3 is going to be to find x. Once again, using y equals mx plus b. But this time, we're going to plug in our m value, the same m value that we solved for. And we're going to plug in our b value that we just got. And this time, because we're trying to find this missing x, we're going to plug in the y value from that half a coordinate. So negative 14. And then my x is the missing x. So I'll start isolating my x by moving the positive 4 to the other side. So that means I subtract 4. Negative 14 minus 4 is negative 18. And I'm left with 3 over 2x on the other side. And then I just have to move the 3 over 2x away from the x. So I divide by 3 over 2 to cancel it out, which means I also divide by 3 over 2 on the other side, which leaves my x alone. And then I'm going to solve the other side by doing negative 18 divided by, and then in brackets, my 3 over 2, like that. And I get negative 12, which is my final answer. So the full coordinate would be negative 12, negative 14, because my x value is 12. Okay, the second way of solving this, I'll show you now. I'll use the same number so you can see that it's going to work the same way. So I'll still have negative 2, 1, 4, 10, and x negative 14. Again, I'm going to start, my very first step has to be to find the slope if it's not given to you. So again, we'll do y2 minus y1 over x2 minus x1 and get our slope of 3 over 2, just like we did last time. Now, this time, what we're going to do as our second step is we're going to go right to finding x. So there is one fewer step in this, so people tend to find this step harder sometimes, because we're going to use the slope formula instead of y equals mx plus b. So what I'm going to do is I'm going to have my y2 minus y1 over x2 minus x1. But this time I'm going to plug in my slope where the m is. So I'm going to plug in my 3 over 2. And then I have to, because I'm solving for x now, I have to use the coordinate with the missing x, and then either of the other two coordinates, doesn't matter which one. So let's do negative 14 minus 1 over x minus negative 2. So I'm using this coordinate and this coordinate. This is my y2 minus y1 over x2 minus x1. So negative 14 minus 1 is negative 15. And then x take away negative 2 is the same as x plus 2. Now, this is where it gets tricky, because if you remember, when you have a fraction like this and you're trying to isolate a variable, whatever is on the bottom of the fraction has to be the thing that moves. So I have to multiply this by x plus 2 in order to cancel that out, which means I have to multiply the other side by x plus 2. So what I end up with is 3 over 2 times x plus 2 equals negative 15. I then have to multiply this into the bracket. So I get 3 over 2x plus 6 over 2 equals negative 15. And I can just simplify this. I don't have to keep that as 6 over 2. So 3 over 2x plus 3 equals negative 15. Then, of course, I'm going to move my 3 to the other side. So subtract 3 and subtract 3, which leaves me with 3 over 2x equals negative 18. And then in order to get the x by itself, I divide by 3 over 2, which means I have to divide the other side by 3 over 2. And x is going to be equal to 18 divided by 3 over 2. Again, you put that into your calculator as 18 divided by, and then in brackets, your 3 divided by 2. And when you do that, you get negative 12. Okay, so you can decide which of these methods you like more. Again, this one does have fewer steps, but this step is long. And this part right around here tends to confuse people, which is why I showed you the other one, even though there is an extra step in it. Okay, but you can pick whichever of those you prefer. The last thing that we're going to be doing today is going over a word problem that involves slope. So when you're given a word problem, I would highly recommend that you start by creating coordinates out of the numbers. So I can see here that I'm dealing with height and distance. So I've got a zip line that is starting off 80 feet high, and it's so slowly descending until it reaches 60 feet high, And over the course of that, it has traveled 300 feet. Okay, so that's kind of what we're talking about here. And if it helps you to draw out these word problems, you know, feel free to do so. But the first thing I'm going to do is write out the coordinates. Now I know that just based on a normal graph, when we're talking about height or vertical changes, that's our y, because the vertical axis is our y-axis. So these are going to be our y values over here, and these will be our x values over here. So my first coordinate is going to be that when the zip line is 80 feet in the air, it has traveled no distance. It's like at the start of the zip line when it's 80 feet in the air. By the time this zip line has gotten 300 feet away, so it's traveled 300 feet, it now has a height of 60. Okay, so at 80 feet in the air, the zip line had traveled no distance. At 60 feet, by the time it had dropped to 60 feet, it had covered 300 feet of horizontal distance. Okay. So step one, I would say, is make your coordinates. Identify what your x value is and what your y value is. Okay, in this case, I know that my x value is the horizontal distance and the y value is the height. Again, that's just because on a graph, when we're moving horizontally, that's x. When we're moving vertically, that's y. Okay, so identify your x and your y, and then identify the pairs of numbers that go together. Step two is going to be to use those coordinates to calculate slope. That's why I'm making these coordinates here. So that was step one. Step two is going to be using our y2 minus y1 over x2 minus x1. So that means 60 minus 80 over 300 minus 0, which is negative 20 over 300, which we can simplify to negative 2 over 30. Or negative 1 over 15. Now, because it's asking what the horizontal distance is going to be at a certain point, what that really means is that it's asking for my change in x. It's asking for how far I've traveled, how much the x value has changed. Which means that in order to solve for my change in x, I first need to know what my change in y is. So that's going to be my next step, is to just figure out what is the change in y that's happening with this new 35 feet that's been thrown in. And so I'm just going to say, okay, to get from the y2 that I've ended up at, from the original y value, how much has changed? So to get from the 35 feet that I end up with, from the original 80 feet, that means that I have descended 45 feet, so negative 45. The last thing that I'm going to do is now say, okay, I know that slope is equal to a change in y over a change in x. So what that means is I can plug in my m value that I already know of negative 1 over 15, plug in the change of y that I know has happened to go from the original height to the height I've ended up with is negative 45, and I can therefore solve in the change of distance. Solve for our delta x, our change in distance. There's a couple ways to do this. I could multiply by delta x to move it to the other side and then divide by -1/15. But as soon as I see a fraction on both sides like this, when our m value is a fraction, as soon as you have two fractions on either side of an equal sign, you can cross multiply, which is actually the easiest way to solve this. That leaves me with -1 delta x equals -45 times 15, which is -675, and then I just divide by -1, and my change in x is 675, and that is my final answer. This thing, this zip line, has traveled 675 feet from its starting point by the time you've descended to 35 feet. Okay, so yeah, so step 3 in this case was find delta y. If it had given you distance at this point instead of height, then you would be finding delta x, but you're going to find delta something, your change in your x or your change in your y. And then your last step is to find the change in delta x, or if you had started with delta x, then finding your delta y using your slope formula. Okay, I know that this is tricky for a lot of you guys to wrap your heads around, these kind of word problems. And really the best way to get better at word problems is just to practice them. So yeah, make sure that you're doing all the word problems from your homework that I assign, and then letting me know if you have any questions about it. Okay, yeah, that's all for today's lesson.